Standard deviation is used for measurement of variability or diversity in a set. It shows deviation from an expected value, which is the arithmetic mean for the set. The higher the standard deviation, the higher is the variation among data values, which means that the scores are highly scattered. Calculating standard deviation. See, GMAT will never ask you to calculate standard deviation, but the questions based on it would require you to have a basic idea of how standard deviation is calculated. So let's take a basic example. Consider a set consisting of the following 8 values. These are the values. Now let's go about calculating the standard deviation. We go about plotting these values. See, the first column represents the 8 values as they are. The second column represents the arithmetic mean of these 8 values, which is 5. And then the difference between the respective value and the arithmetic mean. The sign doesn't matter. It's about the deviation. Whether it's less or more, it doesn't matter. That's why the mod sign. Therefore, 2 minus 5 equals 3. 4 minus 5 equals 1. Likewise, then the square of these values, these are the respective square of the values in the fourth column, then the last column represents the sum of these values. Standard deviation is the sum of these values represented in the last column divided by n, the number of terms, and now square root. Therefore, square root of 32 divided by 8, in this case. The standard deviation for this set is 2. Now some very important observations about standard deviation. What happens if all the terms in the set are increased by a value of x? Imagine what would happen. Suppose I add 10 to each value. 2 will become 12, 4 will become 14 likewise. But then the mean, 5, will become 15, and between 12 and 15, the difference would still be 3. Again, between 14 and 15, the difference would still be 1 again, and therefore nothing will change in these columns. Therefore, the standard deviation would remain the same. Similarly, if I subtract the same number from each of these observations, nothing will change. The standard deviation would remain the same. Now what happens if I double all the numbers? If I multiply all the elements, let's say in this case by 2, so 2 becomes 4, 4 becomes 8, likewise. The mean, 5, in effect, will become 10. Now, see, the difference between 2 and 5 is 3, but the difference between 4 and 10 would be 6. So, see, this difference would double up. The value of square would therefore be 4 times. The value of the sum here, therefore, will be 4 times. But when we take square root, it will again become square root of 4. That is 2 times. So that means if we double up everything here, then the standard deviation would also double up. Suppose I make everything 1/3. Then everything would become 1/3. In effect, standard deviation would become 1/3. So these are some very important observations. If all the terms in the set are increased by the same value, the standard deviation remains the same. If all the terms in a set are decreased by the same value, the standard deviation remains the same. If all the terms in the set are multiplied by the same value, the standard deviation also gets multiplied by the same value. If all the terms in a set are divided by the same value, the standard deviation also gets divided by the same value. Very important. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.